All right, so today's topic will be about heating, the heating curve. So basically, when you heat up a substance or a liquid, what happens? What does the curve look like? So what does the graph of temperature versus time look like? All right, so the question is, what would a temperature versus time graph look like if you heated water? So most people would think that if I had temperature, oops, let me try this. So most people would think that if I had temperature versus time, that as I heated the water over time, the temperature of the water would increase like this, right? So it makes sense. So if I put water on a hot plate, over time the temperature of the water would increase. But it looks like this, but there's some interesting parts to the heating curve that we kind of wanted to discuss today. Before we start, though, we want to define these three things: temperature, kinetic energy, potential energy. So temperature is just average kinetic energy. So it's the measurement of the average movement of particles. Kinetic energy is the energy due to movement. And potential energy, we can say, is stored energy. All right. So let's take a look at a heating curve and see how it is different or the same than what we had thought of. So here is the general curve or heating curve for a particular substance. And so what you'll notice is that instead of when you heat a substance, what happens is it increases over time, but there's certain points where it plateaus. And I was curious to see, what do you think happens at these plateaus? But before we do that, let's figure out which one is kinetic and which one's potential. So I would copy this graph down kind of big because we're going to use it for multiple things. All right, so here we have the kinetic energy. So which parts do you think represent the kinetic energy? So remember, kinetic energy is measured by temperature. So if the temperature changes, the kinetic energy changes. So the parts that the temperature changes is here, here, and here, right? And so these parts represent the kinetic energy. So during these parts, these parts, we have kinetic energy changing. However, so what you'll notice is that there are flat parts. So during these parts, the temperature doesn't change. So what's occurring there? Well, remember, heat's being added. So instead of kinetic energy being changed by the heat, we actually have potential energy being changed. Right? Okay, so exactly what's going on here? Well, the potential energy sections actually represent phase changes. So if you can imagine, there are three phases represented here. We have the kinetic energy here. So whenever we have the kinetic energy, that's going to represent a phase. So these are gas particles moving quickly. These are liquid being heated up. And then this is solid. And so in these, where you see potential energy, it's actually liquid to gas. So therefore, this is evaporation. And then here you would have melting. So, if you think about it, if we were to draw this out, let's do this here. Let's go back. So, if we were to draw this, here we have solid. So as the solid particles, as the temperature increases or the amount of energy increases, they start breaking apart, or they start moving. But once they get to their melting point right here, so the melting point's right here somewhere, what happens is the energy now is being used to separate or to loosen the IMF. So basically, they start vibrating here, and then here, what happens is the energy is being used to, so the energy is no longer used to speed up the particles, it's now being used to basically weaken IMF. And as you weaken the IMF, what happens is it becomes liquid. And so now this starts moving, the particles, once they all become liquid, start moving. And so they start moving faster and faster until they get to their boiling point or the evaporation point. At that point, the energy is being used to break the IMF. So here we break IMF. So now the liquid there's enough energy to break the IMF, and so the energy is used for that. So there's they're moving the same velocity or speed, but in this case now the energy is being used to break IMF. So that's why we don't see a temperature change. So it's almost like you can almost think of it as like a dial between kinetic energy and potential energy. So these sections here, the dial is towards kinetic energy. So that means the molecules are moving faster, because there's always a certain amount of energy. So this is heat energy that's added, right? But then at the melting point and boiling point, what happens is the dial no longer is used as kinetic energy. It's still a type of energy, but it's now added as potential energy. Why? Because potential energy is used to kind of weaken IMF. It's used to change the phase. Okay. All right, just a couple terms though. So there's a certain amount of heat, so the heat of fusion. So this is the amount of heat required to melt or freeze. And then this is your heat of vaporization. It's the amount of heat required to evaporate or condense. Okay. All right. So we could ask a couple questions. So at what locations are they? Is kinetic energy occurring? And you would say kinetic energy is whenever heat or the temperature changes. So we have kinetic energy here, and then where's potential energy being added? We could say B and D, and then you could ask, where is it 100% liquid? And you could say it's right between here and here. Where would you consider to be, if you had a mark on this graph, where would it be 50%, exactly 50% gas and 50% liquid? And you would say right around here, whatever the halfway mark is here. Here it's 50% liquid, 50% gas. Why? Because at this particular point, you're evaporating, and so right in the middle, you would expect to be 50-50 liquid and gas. You say, what is the melting point of this substance? And so the melting is occurring here, right? If we had to label this is solid, this is a liquid, this is gas. So the melting point is right here at negative 60 degrees Celsius. So, and then what is the boiling point? The boiling point will be 60 degrees Celsius right here. All right. So this is pretty much these are some questions that we could ask you. On the next page, there are some possible questions. There's some homework and a key as well.